Okay, so for the next installment of Statistics with R, we are going to look at simple linear regression. So we have this data set diabetes, which you probably will have known. So these are the headers with cholesterol all the way, height, weight, and so on. So we were wondering, okay, for example, can we predict the weight of a person from, let's say, the person's waistline from. So that's the question we want. Okay. So how are we going to do that? Now, essentially, at the end of the day, we are going to construct a formula that looks something like this. The weight of a person equals to some beta 1 of the waist plus the y-intercept, which is beta 0. So what is beta 1 and beta 0? This is where we want to find out. So let's start. We construct a model. And since we are going to use linear regression, it's called LM. Okay. Then the equation is the weight theta, which is then the independent variables, which is the waist. Okay. The data equals to diabetes. Okay, that's it. All right. So this is how you construct the model. It is a simple linear regression because it's essentially y equals mx plus c. It's just a straight line. Okay. So we do a summary of the model and we see, does it work? Okay, so let's say this part. What does it say? It says that the adjusted R square is 70.8%, meaning okay, the adjusted R square equals to 70.8%, meaning to say that 70.8%, 70.8% of the weight can be explained by the waistline. And what is the coefficients B1 and B0, or beta 1 and beta 0? This is the estimate. Okay, so which means that our equation will be weight equals to the waistline, which is 5.931. So this is the coefficient, okay, of the person's waistline in inches for the data, minus of the intercept. Okay. And what it means is this equation has about 70.8%, you can call it reliability. So that is basically how we construct a simple linear equation. So you can consider what happens if we want to have more items. For example, weight. Can you use waist? Can you use hips and so on? So let us just do the same for our, can I predict a person's weight using the person's hip measurement? Okay. So do a summary again. Okay, it has about 67.7% reliability. So you can construct another equation. So here the equation will be waist. Oh, why am I talking about waist? Weight is of the hip measurement minus here. Okay, and I'll use inverted commas reliability, because it's actually not perfectly reliability, is about 67.72%. So since waste you can estimate, heap you can estimate, can we put the both together to estimate? So that is for multiple linear regression. But for simple linear regression, we only look at the dependent variable um, explained by one independent variable. When the dependent variable is explained by more than one independent variable, then uh, uh, that becomes a multiple linear regression. So one more thing is, what does this p-value means? This p-value means that it's actually testing the null hypothesis that the r square equals to 0. So it tells you that the p-value, which means that the r square is significantly different from 0. The p-value is less than 2.2 times 10 to the power minus 16. Okay, that's all that I have for simple linear regression. See you next round.